we are going to introduce those graphs and draw them ourselves on the side of the page, because their graphs that they have a lot of extra grid points. The way that sine and cos are graphed is, so we'll start with the graph of sine of x. And we're going to label the value of sine of x here. So this is our x-axis. This is our y-axis. So x is putting in our angles. And y on the y-axis is the value of sine. So a couple of things. Think about our unit circle. And when we graph this, the key things that we're going to put into our graph are the axes family of our unit circle. So if we're going around our unit circle, here we have an angle of 0. At the top we have an angle of pi over 2, an angle of pi, and an angle of 3 pi over 2. If we think of our axes family, what is sine of 0? So I'm going to put all 4 axes family along here. Pi over 2, pi, 3 pi over 2, and 2 pi. And you could do it in degrees too. In degrees it would be 90, 180, 270, 360. What is sine of 0? Zero. What is sine of pi over 2? 1. So on our y-axis here, we're going to go up to positive 1, and we're going to go down to negative 1. Sine of pi over 2 is 1. Sine of pi, 0. Sine of 3 pi over 2, negative 1. And sine of 2 pi is back to where we start again. And we make a nice sort of round, circle-y curve, and it would keep on going right through there. So one thing that we're always going to do when we graph sine is think about splitting it into 4 sections, like our 4 quadrants, and then be able to graph it. If we look at the graph of cosine, again, here's our x values, which are our angles, and our y values are equal to cos of x. If we look at all 4 quadrants again and split this into 4, so what I like to do is I like to make a line where I am going to put 2 pi, and then I like to cut it in half and then cut each of those in half, so I get 4 equal sections. Pi, pi over 2, and 3 pi over 2. And same thing with sine. The biggest cos ever gets is 1, and the smallest cos ever gets is negative 1. What is cos of 0? 1. Cos of pi over 2. Cos of pi. Negative 1. Cos of 3 pi over 2 back to 0. And cos of 2 pi is back to 1. And we get exactly the same shape as before. And if you would keep going, like the next ticky mark that you would make would be 5 pi over 2, which is coterminal with pi over 2. And we already learned how coterminal angles have the same values. And so we can see how our sine and our cos graph repeat themselves over and over and over again. So a couple of things you can highlight in your notes as far as definitions go. A function that repeats its values in regular intervals over its domain is called a periodic function. And the length of that period or cycle is called its period.
Is there one that repeats its values over the range?
No, we look just mainly at ones that repeat themselves over the domain. I mean, technically, if you would do an inverse of your sine graph, and you do the entire inverse image, it would be going straight up like that, but then it wouldn't be a function. So anything that repeats itself on its range then isn't a function, and then for the most part we don't look at those.
Do we only graph sine inverse with axis value values?
No. We're going to figure out how to do it with any values later, especially when we're dealing with temperature or dealing with sunsets, right? It's not like, oh, I wonder what the sunset's going to be on 3 pi. Well, that doesn't make sense, right? But you can say, I wonder what the sunset's going to be on February 3rd. So there's a number, but it doesn't have anything to do with pi. So we have to figure out how to work with that. So here is our sine graph. And unlike, I'm just going to put these dots along here just so we can visualize it compared to our graph. Notice they put a lot of extra lines on here. Okay, they have a whole grid, and I think that that grid adds some confusion to it. But they're saying if you want to figure out what the period of sine is, you need to figure out, start from one point, and they chose this point, and then say, when do I get back to that point? And a minimum and a maximum, or a minimum or a maximum, are great for sine, because the next time you hit a minimum is right there. How far is that? How far is that from that point to that point? Well, it might be even easier to see the period if you start at 0. So I'm going to put a square around 0. At 0, what's happening to my graph? At 0, I'm in the middle of my graph going up. When does that happen again? When am I in the middle of my graph going up? That happens again here at 2 pi. So if you start at 0, in this case, you can easily see that the period of sine is 2 pi. If you measured from this value to this value here being negative pi over 2, and this value here being 3 pi over 2, and you did 3 pi over 2, subtract negative pi over 2, you would get 2 pi as well. So no matter which 2 points that you choose, if it's repeating itself at that, the distance between those 2 points will be 2 pi. Another important definition, and as far as highlighting it goes, it's highlighted on the next page. Amplitude. Okay? The amplitude of a function is the distance from a maximum or a minimum to its center line. So if we go back to our sine graph, okay, if we even go back to our graphs, which are less busy, if we want to say, well, what is an amplitude? Our amplitude is this distance from here to here. That's an amplitude. What is that distance? 1. As far as figuring out your amplitude, sometimes you can tell where the center line is and what your maximum is, and you can just find out the difference. Sometimes you only know a maximum and a minimum. So let's say we go back, let's go back to Iqaluit, and we know, I tell you that the maximum here is at 22, and the minimum is at 4. What is the amplitude? The amplitude, the definition of the amplitude is the middle to the top. I don't know exactly where my middle is because I made up numbers. Maybe, but it might have been shifted over. Okay? According to where I put my numbers, it's not accurate. So you can't just judge by the middle. If I tell you the maximum is 22 and the minimum is 4, what is my amplitude? 13. Okay? 13. No, not 13. Wait a minute. Yes, 13. So if we do 13 here and 13 here, what does that make? That adds things up to 26. Does that make sense from 4 to 22 to be 26? No. So it's not 13. It's 9. Does 9 make more sense? If you go up 9 and up 9, do you get to 22? Okay? So how do we figure that out if we just are given a maximum and a minimum? Well, what you could do is you could say, well, what is the distance between the maximum and the minimum? 22 minus 4 is equal to 18. The distance from the maximum to the minimum is 18, and from the maximum to the minimum is always going to be 2 amplitudes. So if we know that the distance between the two is 18, we could figure out the amplitude to be half of that. Okay, so back to our sine graphs. We have our amplitude as the distance between the center line and a maximum, or the center line and a minimum, and our amplitude is 1. So I don't know if we want to write that. Some other things about our sine and our cosine graphs. The domain of our sine graph, since it goes on forever, is everything. So another thing we can highlight. Our domain is everything. A more complicated thing to write are the zeros. How many zeros does our sine graph have? It has an infinite. It has one here, 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 and it keeps on going. If we started to list them all, we'd have 0, pi, 2 pi, 3 pi, 4 pi, 5 pi, 6 pi, 7 pi. We'd also have negative pi, negative 2 pi, negative 3 pi. So what is a way that we can write those? We have all the values of pi. Okay? So our zeros, which are blah, 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 if we wanted to write them out, all of them, we notice a pattern that it's just k times pi. Yes?
Why isn't k any real?
Because integers mean positive and negative whole numbers. Pi itself isn't the whole number, but the number in front of pi has to be a whole number. So just like when we look at the pattern, there's plus or minus 1 pi or plus or minus 2 pi. The number in front of pi has to be an integer. You can't have a rational number. You can't have 1.5 pi. That doesn't make sense. Yeah, 1.5 pi would be, here's 1 pi, 1.5 pi would be 3 pi over 2. And that's not one of them. We have a maximum value and a minimum value of -1. So the range of pi is from -1 to 1. We're going to look at the same concepts with cosine. Domain of cosine, everything. The zeros of cosine are more complicated because if we think about where the zeros are, and again, it's probably even easier to see them from our graph where we just labeled the axes family, can you see that you have a 0 at pi over 2, 3 pi over 2, 5 pi over 2, 7 pi over 2? So how do we write that? Because we see they're all over pi over 2, right? And then the number in front is always odd. Yes?
In the thing, it says it's 5 pi over 3.
5 pi over 3 in the thing. So if we go and look at that, okay? And this is why I'm not really... Okay. 5 pi over 3 is here.
No, but it's all over 3.
It's all over. That's why I don't like, that's right. That's why I'm not happy with their graphs. Because all of their 5 pi over 3, 4 pi over 3, 2 pi over 3, pi over 3, all of those points that they have don't match up to nice points on our graph. Well, they do. They're nice points. Don't want to make them feel bad. But they're not on our maximum, our minimum, or on our center line. Okay? If we think, what is cos of pi over 3? Well, that's on our unit circle, that's a half. And that's where that point is. But that doesn't really help us with finding the zeros. And they haven't labeled any of our zeros. They haven't labeled pi over 2. They haven't labeled 3 pi over 2. So that's where our graph here is nicer for seeing the zeros. Because we can see it's pi over 2, 3 pi over 2, 5 pi over 2. What's the next one going to be? 7 pi over 2, then 9 pi over 2. And we notice a pattern. The pattern is odd pi over 2. And it can be positive or negative. But can we write that? Is that mathematically correct to say equals odd pi over 2? Well, no, we're kind of mixing an English word in there with math. So then the question is, how do we write an odd number? Okay. Well, this one I did already. I'm on this one. Here we go. The zeros are 2k plus 1. So this is one way to write an odd number. Does that make sense? That, because we were thinking, this is what we were thinking, odd pi over 2. And they say you can make an odd number by making this 2k plus 1. What happens when you multiply any integer by 2? You get an even number. So if you have an even number and you decide to add 1, you're going to get an odd number. Yes? No, you don't have to do this. You go straight to the formal way of listing them all. Okay? I'm going to put right here, hopefully before the bell rings, or another way that you can do that is you can notice that if we start with pi over 2, which is right here, or going back to our graph, which is easier to see, if we start with pi over 2 as our first 0, how much do we have to hop to get? We have to hop pi in either direction. So some people like this better, writing, instead of writing this 2k plus 1, which is odd pi over 2, they say, I know that I start with pi over 2, and then I can add or subtract pi, or add k pi, where k is an integer, as many times as I want to get all the rest. Sort of like what we did with coterminal angles. And finally, max and min and range are exactly the same for cosine as well.